Okay, guys, where do you want to start? Yep.
4 point.
Yes, let's go to 4.6, which is maybe on the back of the review, or is it on the front? I don't know. Okay, on the review sheet on the front. So 4.6 is inverse trig functions. On this particular quiz, you can use your colored unit circle. Remember the idea that you eventually won't be able to use the colored unit circle, but these two quadrants are for cosine, and you don't have to do anything tricky. These two quadrants are for sine and tangent. And the trick is, if you wind up down here, you have to call this like negative pi over 6, negative pi over 4, negative pi over 3, and negative pi over 2. Okay? All right. So this question is asking, where is the sine negative 1/2? Let me see if I have a slide I can stick in here, or is there already one? Oh, there is one, kind of. Okay. So it was sine of negative 1/2? Yes?
But we don't have that one.
Okay. Well, I apparently have more practice than you do, so, but this is what the quiz looks like, is what mine looks like. Remember, Miss Abruzzo and I were trying to cut back on giving you so much extra practice, but apparently this is the old version and you have the newer version, so we'll go over the ones I have if that's okay. So where's the sine negative 1/2? Would it be down here? And what would you call that? Yes. And you can use your colored unit circle and it should have that. Okay, remember tangent is the icky one. Tangent we really have to think about, but this is asking where is the tangent? Negative square root of 3 over 3. So the tangent is negative down in this quadrant. So I have to think if I put y over x here, if I put y over x here, if I put y over x here, so which one of those is going to turn out to be a negative square root of 3 over 3? This one, right? So this would rationalize to this. So this is the answer we want, but you can't call this 11 pi over 6. You have to call it negative pi over 6, which is renumbered on your colored unit circle, but eventually you're going to have to do without. Okay. Where's the cosine 0? So cosine is x, and it is 0 up here at pi over 2. Oh, good grief, how far if you'd go the right way. Okay, this one, where is the tangent negative 1? Can anybody answer that? Be real careful. You're not looking for a negative 1 in the x or y. Yes, you're looking for when you put the y over the x, you'll just get negative 1. It's down here because you're putting this over this, so this becomes negative 1 for tangent. Hey, I went the right way. So it's negative pi over 4. All right. So this is just a two-stepper. You answer this question. Is that asking, what is that asking? Can someone say in words?
Where?
Yes. Where, okay, the negative 1 tells me, or the arc sign, either one tells me I'm looking for where the sign is negative pi over, or square root of 2 over 2, and that answer is negative pi over 4, and then it wants the cosine at that spot. Now, you can't do arc cosine there, but it just wants the cosine. So when I go down here, what is the cosine at that spot? Yes. Well, I can't do it twice in a row correctly here. It's positive because they have the same, sine and cosine are the same at that spot, but the sine is negative and the cosine is positive. All right. The next one, is this going to be on my unit circle? No, these are draw. Okay. I don't have a lot of room, but arctangent is negative. What quadrant is that in? You have to figure this out. It says on the quiz, Alexis, will you put that away, please, and review with us? It says on the quiz that draw, it says above these kind of question, it says draw and make sure you're in the right quadrant. Okay, so I'll give you a hint. Arctangent is negative in quadrant 4. So you would have, let's see, y over x or opposite over adjacent. Which one would be negative? Okay, so the 4 would be negative. If you do Pythagorean theorem, do you know this one, guys? Yeah, I'm just going to get a 5. So what is the sine of that angle? Opposite over hypotenuse or negative 4/5? Yes, no? This one, where is the arc sine positive? Arc sine is never in quadrant 2. Yeah, the only place either sine or cosine are positive, arc sine or arc cosine are positive in quadrant 1. Sine is opposite over hypotenuse, or y over r. If I do Pythagorean theorem, I'm going to get 11 squared equals 3 squared plus x squared, or 11 squared minus 3 squared. So the square root of, what's 121 minus 9? Ew, 4 goes in there, I think. What's 112 divided by 4?
20.
So does 16 go in there? 112 divided by 16? 16 times 7. So we'd have 4 square roots of 7. All right, now we need the cosine. All of that simplified down to 4 square roots of 7. So cosine is adjacent over hypotenuse. Whoops. Yep, that's not right. What did I just write? Should be 4 square roots of 7 over 11. Sorry. There is a lot more practice on inverses. You should have worksheet, you had a book assignment on it, and you had worksheet 22, and there's more practice on it on worksheet 28 from the last packet. Okay. Sketch and write an expression to represent this. This is the one where you're going to have letters, and you got to be careful not to simplify things you can't. Okay, these are always in quadrant 1, and cosine is adjacent over hypotenuse. We good so far? How do I write an expression over here then? So a squared plus question mark squared equals 1 squared. I subtract. So I get question mark squared equals, well, 1 squared is just 1 minus a squared. And then I square root. Can I simplify?
No.
So I have square root of 1 minus a squared. Now what is the tangent of that picture? Can I simplify that?
No.
All right, anybody need to see another one of any of that? Okay. What can I do next? By the way, I keep forgetting to tell this class this. I told the other class that I think I can most easily find it for you here. this is the actual homework check that's due tomorrow, guys. These two that say 5.3 are crossed off. I'll put them on the next one. Did I tell you that at some point? So you are turning in a homework check tomorrow for summative 4, but we have not done 5.3. So you just have 4 things due, 5.1 and 5.2, bookwork, and then the stuff on 4.6, the bookwork and the worksheet. Everybody good? I put it in the Google Classroom and I told the other class, but I keep forgetting to show you guys. Okay. Now I don't know where I am. All right. What do you want me to do next? Yep.
Wow.
3 and 4. Are these the right ones? Okay. Okay. Find angle E. By the way, there are no pictures on tomorrow's quiz. It's like the ones we did yesterday where it says capital F equals this, little e equals this, and you have to draw the triangle yourself, okay? But this one wants us to find E. Anybody tell me what we need to do? Mackenzie. Law of sines or cosines or area formula here? It doesn't want us to find the area. Otherwise, we could use the area formula. Could use Heron's formula to find the area. It says to find angle E. Okay. We don't know any of the angles, so we can't use law of sines. So we have to use law of cosines. Okay. Which one do we want to start with? Yeah, the one across from it, so the 21. Okay, somebody tell me how it goes. 21 squared equals?
8 squared. Oh.
The 26 squared. Okay. Nope. 26 and 28, be careful, yep. Cosine of angle E. All right, what do we want to do next? So 21 squared minus 26 squared minus 28 squared all goes on top. And what's going to go on the bottom? Yep, we need to divide all of this so that cosine of E will be by itself. So we have down here a negative 2 times a 26 times a 28. All right, I am not going to use my online calculator for this because it takes longer. Somebody tell me what you get for the top. I got negative 1019. Anybody else get that? It's probably wrong, so somebody tell me. Negative 1456. Anyone get those two numbers? I'm going with it. If you have two negatives, what are you really putting in your calculator? Positive. So you could type it as a positive, but you're going to do inverse cosine of that. Okay. What mode do we need to be in? It wants an answer in degrees. Does it matter what mode you've been in up till now?
No.
Only when you touch sine, cosine, or tangent. So I didn't check my mode yet, but now that I'm going to do inverse cosine, I want to check and make sure I'm in degrees, and I am. I'm going to do second cosine 1019 divided by 1456. I can put the negatives in, but they're going to cancel. I got 45.6 degrees. Do I need to check for a second solution? No, only law of sines. Questions? All right, this one says find AC, which would be this here, or we could call it B. Law of sines or cosines?
Cosine.
Yeah, 28 degrees is across from 10 yards. In the same way, the sine of 127 degrees is across from B. That's just a straight up typing question. It's finding a side, so there's not more than one solution. So 10 times the sine of 127, either close your parenthesis or hit enter and then divide by the sine of 28. I got 17.0. Questions? I went kind of fast on that one. Is there one where you have two solutions? Let's try 6 real quick. Triangle ABC. A is 63 degrees. Side C is 35. Side A is 34. And we're supposed to actually find angle B. Can we find angle B right now? So what are we going to have to find first?
5.
Can we find side B? Yeah, we can use law of sines to find angle C. Okay. On the quiz, it's not this complicated. It would find angle C. Do you want to just do that rather than make it more complicated than it's going to be on the quiz?
Yeah.
All right, so if we have the sine of 63 is across from 34 in the same way that the sine of C is across from 35, what's going on here? You're finding an angle using law of sines, so you have to think about what? 2 possible solutions? Sometimes there aren't 2 possible solutions, and we can talk about that. But, okay, so cross multiply 35 times the sine of 63, close parenthesis, divided by 34, or hit enter and then divide by 34. Okay, I have the sine of C is like 0.917, blah, blah, blah. So now I do second sine of that number. Someone tell me if they're not getting the same number. Okay, I got 66.5, or how do you find the other possibility? Do 180 minus that angle, right? So 180 minus 66.5 is 113.5. Okay. Is there any reason I have to eliminate 113? It has to be bigger than 63, right? Because it's across from a longer side. And both of those are bigger than 63. Can I have a 113 if I have a 63? Yeah, it's like 176 because this was a 0.5, but it leaves a little tiny bit of room for another angle, right? Now, if we had to find B, after we put the 2 different choices for C down, we'd have to subtract everything from 180 and find B. But I didn't make it that hard on the quiz. So let's just go with C, okay? So you would say angle C could be 66.5 or 113.5. Yes. It doesn't matter. You could still have, there will be a triangle that exists that would have a 63 and it would be, yeah, you can't assume because it is entirely possible. It would look funny. Let me draw it. 63. This would be obtuse. I'm not doing a good job. Okay, one more try, half bar, and then give up. So this would be the 113. This would be 63, and then it would make a really tiny little angle up here. But these 2 sides would still be 34 and 35. Do you see how they wouldn't be much different from each other? Okay. It is possible. You cannot, that's why we don't know. It goes back to this. Did I talk about this yesterday, that your geometry teacher said there's no theorem that exists that says angle side proves triangles congruent? Remember geometry teacher saying that? You can use SAS, ASA, AAS, but there's no ASS, okay? And that's the reason, because we were given an angle and 2 sides, and it actually determines 2 different triangles. All right, what else? How more questions? 5-1, 5-2, do you need to see an area example? Everybody know how to do area? There's two formulas, right? 1/2 side times the sine of the angle. Or there's a formula that says you add up all the sides, you divide that by 2, and then the area is the square root of that times the difference with each one. This is pain in the neck, but it's not that hard. Except you have to add before you divide by 2, right? Somebody did it wrong because they just didn't complete that right. All right. I don't know that that's on there anyway. It might be this one, but there is one area question. All right. What about homework questions? Or I can come up with some practice on 5-1 and 5-2, whatever you want. Seriously, guys? Marissa, do you have some? 317:38. Okay, it says this is the 5.1 assignment, and it says rewrite as an expression that does not involve a fraction. Well done. All right, I'm just going to go with it. It's missing an X, but that's okay. All right, so this is how we start. It's simplify, and it can't have a fraction anymore. Ideas? You want to do sines and cosines? Okay. There's actually a faster way to do this. Actually, I don't know. I think this will work out. 1 over minus cotangent, which is, okay. Now what? Yeah, they do have a common denominator already. So the top stays this. The bottom would be 1 minus a cosine all over a sine. Then what do you do? Well, we currently have the sine of x is being divided by this. What do you do when you divide? Yeah, and it's not going to be as happy as you think it's going to be, because what happens? No, we don't, but we don't get anything nice. What do we still have? Yes, we have a sine squared over 1 minus cosine. Now, there's a couple ways we can talk about this. We could do a trade for the top and factor, but I don't know if you remember this, but on the 5.1 notes, there was a list of things to try. It said change the sines and cosines, look for Pythagorean identities, look for factoring you could do. It said multiply by a conjugate. What is a conjugate, guys? Like if the denominator is 2 plus the square root of 3, the conjugate is 2 minus the square root of 3. What would the conjugate be here?
1 plus cosine.
Yes. So if we multiply top and bottom by 1 plus cosine of x, what will we get on the top? We'll just have a mess, sine squared, and a 1 plus cosine. I'm not even going to bother to distribute. But what do we get on the bottom when we FOIL that together? You'll have a 1, almost, Keaton. Yes, and the order matters, right? Because the cosine squared is what's negative. You'll have a 1 minus a cosine plus a cosine, which cancel out, and then minus the cosine squared. All right, guys, what is a 1 minus cosine squared? Do you know where he's getting that? Yes, cosine squared plus sine squared equals 1. So a 1 minus the cosine squared over here leaves a sine squared. So now I have sine squared over sine squared. Can we? Why? Because it's multiplication. So we get 1 plus cosine. Okay, I did this problem in 2 steps because I'm a nerd. And right back here, I recognized that if I multiply by a cosecant of x plus a cotangent of x, what do I get in the denominator? Cosecant times cosecant is cosecant squared. The inside two cancel each other out, inside, outside, and then I get minus cotangent squared. What is that equal to? Cosecant squared minus the cotangent squared. It's, well, no, it's just on the sheet. It's one of the identities, right? It says 1 plus cotangent squared equals cosecant squared. Did you find it? So cosecant squared minus cotangent squared is just 1. That got rid of the denominator right there. Now on the top, I have this times this, and this times this. What is sine times cosecant? What's cosecant? 1 over sine, right? So sine times 1 over sine is 1. And then cotangent was cosine over sine. So when I multiplied it by sine, this went away. I would have showed some more work, but I'm trying to squeeze it in there, okay? So I didn't put one like that on the quiz where you'd have to know to multiply and get rid of the fraction. All right, what else do you want to try? Nobody has any more questions. Marissa, you said, do you have some on 5.2? Or still on 5.1? 5.2, number 5. Okay, this is a tricky question. Actually, several of these on this assignment require that you factor. And I'm not sure there's one on the quiz that does require that you factor. This one would be easiest if we factored right from the beginning. But you could change it to sines and cosines. I did it that way with somebody earlier today. But either way, at some point, you're going to have to factor. What could I do right now? I have this term and this term. No ideas? When I talk about factoring, what can I take out of both of those terms? Okay, if I take a cotangent squared out, what will be left from this term? Okay, but if I divide this by cotangent squared, I still have what back here? Minus 1. All right, what's a cosecant squared minus a 1? Yeah, it says on the sheet 1 plus cotangent squared equals cosecant squared. So if I subtract the 1 over to the other side, cosecant squared minus 1 is times a cotangent squared. Cotangent to the 4th. Whoops, no equals, sorry. Checks right there. That's a shortcut. Could have done it with sines and cosines. It's kind of miserable. All right, what else? You sure? Zoe? Any? Anybody else try the homework? This guy? 7 or 9? Let me do 9. I can probably do both. I'm just going to do questions until you ask me to do something different. Okay, what can we start with here? You want to work on left side or right side? I have no idea how to make secant into this mess, right? So I think we should work with the left side. This one is already in terms of sines and cosines. What is tangent? Okay, can I cancel these cosines? It's addition, not multiplication. Yep, in the middle here. The only way we can combine things with addition is to get a common denominator. What do we need to multiply this one by? Okay, because the common denominator will have to have a cosine and a 1 plus sine. So we need to multiply by cosine over cosine and 1 plus sine over 1 plus sine. That's the step you have to show. You can't magically get a common denominator without showing me how. Okay? Now, the new denominator will have a cosine and a 1 plus sine. And yes, I forgot my thetas and I'm going with it. Okay. So what will happen over here? Cosine squared plus what happens over here? Can I distribute? Sine plus sine squared. Why is any of that good news? You are allowed to add in any order you want, right? So I can add these two together and get a 1. You need to rewrite that step so that you have 1 plus sine over cosine times 1 plus sine. Now can I cancel the 1 plus sine?
Yeah.
Yes, but I can't do it up here, guys, because there was adding and subtracting going on still, right? So you got to rewrite it before you try to cancel it. Otherwise, I'm going to give you an error. Now, what do I have left? Be careful. Yeah, 1 over cosine, which is secant, which is what they wanted us to get up top. Anybody else? Doing your homework for you. Yep. There is one where you have to get a common denominator. What's happening here? Oh, don't do that whole not responding thing. There we go. All right. 1 over cosine divided by sine minus sine over cosine. What do you want to do now? Yep. Okay. What would the common denominator have to have?
Sine.
So this would get multiplied by a cosine over cosine, and this would get multiplied by a sine over sine. Okay, what happens up here? Yes, cosine times the reciprocal of cosine. Well, it's not written very well, but this cosine would be over 1 because it's cosine times the reciprocal of cosine, so it would just be 1, and then you'd have a cosine sign in the denominator, which is the new denominator. And what do you get back here?
Sine squared.
Okay, now what? 1 minus a sine squared is a Pythagorean identity. It's a cosine squared. And our denominator had a cosine and a sine. What do you mean take it out? Okay, so cosine squared means cosine times cosine, and you wouldn't have to write it that way necessarily. I'm just trying to make sure that you realize there's still one of them left, right? Which is all right. I wanted to see, does anybody need more time? Do you may go back up? Just leave it for a second? Absolutely. You good? Number 16 or number 15? One of those is probably on the quiz. You want me to do 16? Didn't assign either one. I probably should have assigned 16 instead of 17 because 17 is really weird. I can do 17. Come on. There it is. Okay. How to start this one? Yeah, it's going to need a common denominator, so I'm going to have to rewrite it because I don't have room. What am I going to be multiplying this guy by? And over here, 1 plus sign. Okay. So the new denominator is going to have a 1 minus sign and a 1 plus sign. What's happening up top? Cosine times 1 is cosine. Cosine times negative sign is a, cosine, sine, cosine, don't matter which. Over here we have a plus cosine. And then we have a plus cosine sine. Okay, what happens? One of these and one of these subtract away, right? So what's left up there? Over, what do you think we need to do down here? Yeah, we need to FOIL that together. We get 1 minus sine plus sine, which cancel, minus the sine squared. Then what? Yes, 1 minus sine squared is a Pythagorean identity. It becomes 2 over cosine divided by cosine squared. Then what? Okay, so this was really a cosine times cosine squared, or a cosine times a cosine. So one of those will divide out. I end up with 2 over cosine, which is the same as 2 times 1 over cosine, or 2 secant, which is the same as up there. You don't have to show every little step right there. If you 2 over cosine is 2 secant, I'm fine. There is one like that on the quiz. Either like that one or like 15, which is very similar. Anybody, something still on 5.1? Need to see area. Let me do this one. This is a factoring question in my mind. Guys, if I had a to the 4th minus b to the 4th, how would that factor? A squared minus b squared and plus b squared. Okay? So this one factors cosecant squared minus cotangent squared times a cosecant squared plus a cotangent squared. Did I start this one yesterday? No? Okay. One of those is an identity. That's why I didn't trade cosines and cosines. Okay, one of those is an identity. A trig identity, Pythagorean identity, sorry. They're all trig identities. Cosecant squared minus cotangent squared is 1, right? This one right here is a Pythagorean identity, and it turns out to just be 1. So we have 1 times, which does nothing, right? 1 times does nothing, but we have cosecant squared plus cotangent squared. Okay. What word do I not want anymore according to this? I don't want a cosecant anymore. What can I trade a cosecant squared for according to our sheets? Another trade. Cosecant squared is? It's right on your sheet. What does it say? Cosecant squared is?
1.
No. 1 plus cotangent squared. Huh. Why is that a good thing? We had this one traded for a 1 plus cotangent. We had this one back here was a cotangent. Does that give us what we need? We can add those cotangents together, and then we still have a plus 1. And that's what it said up here. I wouldn't put that on a quiz right now, but 30 seconds, minute, 2 minutes. What else? Anything off 5.1 still? 5.1 bookwork? One more? What do you want? Anybody do their 5.1 homework? It was 47 assigned? Nope. 26, 27, 28, and 29 were all assigned. Anybody need me to do this one since I have it? Yeah. What do you want me to do, Tara? 15. Yes. This is a draw question. We know these two things. Whoa. Sorry. Out of control with the tablet here. Know these two things. Which, by the way, if secant is negative, then the cosine is the flip of that, right? We also know that. Okay. And the sign being greater than 0 means positive. So if I do this real quick, all students take calculus. The cosine is negative, so it can't be here. This means cosine is positive, that's C, right? Can't be there. And it says the sign is positive, so we have to be in quadrant 2. You good? Okay, so drawing my bow tie triangle in quadrant 2. If the cosine is negative 2 over 9, that would be adjacent over hypotenuse. Then if I do 81 minus 4 is 77. Somebody help me. Is that right? 81 minus 4? Okay. It wants the cotangent and the sine. It's positive, right? Because we went up. So the sine would be square root of 77 over 9. And the cotangent would be adjacent over opposite. Yuck. Negative 2 over square root of 77, or negative 2 square root of 77 over 77. Picked one with nice numbers, huh? Yuck. Anybody else? Yeah, I did like half the homework. I hope some of you turned some homework in. All right, quiz tomorrow. Don't forget, if you wanted to do a retake on something after you finish the quiz tomorrow, you need to let me know by today. By the end of the day today, tell me what it is you'd like me to have ready for you to take tomorrow.